family member.
Hey, welcome back to Casual Code Talk. So, I was having trouble with this one earlier today, so I actually looked at the solution, and now I'm going to try to do it over again. So that's just something that you guys should do if you don't know how to actually do the problem. You could just look at the answers and then try to do it yourself after. That helps a lot. So, a concept that I haven't gone over in a while is this recursive. Well, first of all, let me explain the problem, because I guess I missed that, because the first part of my video is not here anymore. So what we're doing is we're converting digits from a phone to the to all the combinations of letters it could be. So all that possibilities. So like for 2, 3, for example, the 2 is ABC, so then we have A's, B's, and C's, and then we have 3, which is DEF, which is going to be all the combinations, like AEF or DEF, DEF, DEF. So you have all the combinations here, and that's what we're returning, a vector of strings. So a concept that I forgot about last time was this idea of recursively adding the first letter, and there's like a first sequence of things that you go through, and then like a second one, and you keep you like pop back after you finished. Okay, let me go through the idea first. So one of the idea has like this helper function, void helper. I'll just call it helper letter combination so we don't get confused. And then so what it's going to take in is going to be definitely the digits. You definitely need that. And then you need the permutation, and then the index, digit, index. Okay, and then we're gonna do vector string solution. So something about LeetCode is that you could have these it's a class, so you could have private member variables here and then return these, which is kind of nice because it allows you to have more freedom in your design of the program. So then I'm gonna call helper letter combinations, and for recursive functions you're always going to want helpers. Yeah, because usually like you want a helper because you want to be able to have more inputs, more specific inputs usually. Okay, so where do I start this off? I'm going to always be passing through digits. So, maybe I'll make this a private variable so it's like less things to pass through. So digit int dig gets nothing. Okay. And then let's like get dig gets digits. I'll shorten it up. I usually like smaller things. Okay, so that gets that. Then we don't need to pass this through. And then permutation. Okay, so I'll get back to this, but for now I'm going to keep it as just nothing, blank like that. And then index I'm going to start at 0. So basically I am going to go through all the iterations of this, and I'm starting off on index 0 and a blank thing. Okay. Yeah, and then I'm going to return solution. Okay, so here the main meat of this is going to be So we're going to have string str gets d at d index. So this is going to get it the number. And then, oh yeah, okay. So this guy also had this really cool, nice little function called string get letters or something. It was pretty clever. So, and then it's going to take in a car C. Okay, so how this worked was, it was basically just a switch statement, switch, I think I'm getting better at these, switch C, and then we're going to do the cases of numbers. So if it's 2, wait, that's not how you do a case. I think it's like this. Yeah, the automatic indentation probably means that's correct. So if it's 2, I'm going to be returning, I don't know why I did that on a separate line, return ABC. Great. And then case, I'd like to copy and paste this because I'm not like the fastest typer. Okay, so that's, nope. Well, I don't like how it's not doing that. Okay. 3, 4, 5, 6, 7, 8, 9. Yeah, I don't know if that saved me any work. Okay, 3, and then DEF 4, and GHI, and 5, and JKL. It's kind of therapeutic to just do this. Makes you feel like you're doing a lot. MNO 7 is gonna be oh, 7 is PQRS. I didn't even notice that. 7 is also 3 things, or 4 things, I mean. 8 is TUV. And 9 is going to be another 4-letter, W, X, Y, and Z. Okay, so now that I got that, I am going to do get letter, that thing. Okay, so now the string is going to be turning our single number into the 3 or 4 letters, actually. So then, after I do that, I'm going to go through that. So int I equal 0, I is less than str. Okay, maybe I could think of a better thing for str. Let's call it letters. Okay. So letters dot size, and then I plus plus, and then what I'm gonna do is okay, so here's the idea of permutations. You are going to do perm plus equals letters at I. So you're going to add, so like let's say we had 2, 3, for example. So we are first going to add this A. Okay, so we add the A to the permutation, and then we are going to call helper letter combinations with perm, so the new updated perm, and the D index plus 1. Why plus 1? Because like we want to go to the next level. You know, we, like, even though you think we're going to go to D, how are we going to get back to the E? Well, after we, this is like the recursive leap of faith, kind of. So another thing that the solution that I was looking at kind of taught me was a cool push or pop back. So this will take off the last letter in perm. So it's like it's like for the first iteration, when we're looking at the first thing, it's going to add a, go through all the variations of a and the next number, which is like from 3. Then after that's all done, pop back a, so you take off the a, and then you go to the next letter in 2, which is b. And then you go through b and then so the funny thing is the index is going to be 0 again, because we pop back to the first level. This would be a lot easier to do if I had a tree or something. Maybe next time I'll draw out some pictures. Okay, but yeah. So this is like an idea of permutations. You add something, then you call a helper to oh, I'm not going to answer that right now. Okay. Well, maybe I should have. That might have been funny. Okay. So the idea of going through permutations, that like I've seen this idea in other coding questions. You got to add something, call a helper function that goes to like the next level of this iteration, then take it off and like and go through this. So this is like a way to do permutation stuff. And I definitely have to review this, and like when I review this I might go through it in a video also. Okay, but then you're probably thinking, when do you add this back? So so you're going to add this back when if perm.length equals oh wait, d is supposed to be a string, equals d.length. So when that is true, when they both equal each other, then you know you've got into the last one and you should be pushing it to your solution. So solution dot push back perm, and you're done with this iteration, so you just want to return here. This is the only way you could return once you add all these things. Okay, so now we're almost done. So here, just a quick base case. If digits is empty, so always got to think of the empty string, we're just going to return solution. So something that I thought, like, why is this even necessary? I thought this would handle it here, because after all, it'll just, if there is nothing in it, then the first iteration, the length of perm is 0, and since its digits are empty, it's also 0. So you'd think, okay, just pushing back nothing, that's an empty solution. Well, it's actually not. You're pushing back an empty string, but that's still something. You literally, like, when there's nothing in the digits, you want to push back nothing, not even an empty string. Okay, so let's see if I did this correctly. And perm, oh, I should probably, so this is going to be a string perm and an int index. Okay. Line 23, get letter. What am I taking in? I'm taking in, it says, this is D at D index. D is a string. Oh, get letters. Function not declared in script. Okay, yeah, I probably should have got that faster. And then also probably a spelling error. Helper, it says error expected semicolon. Oh no, it's here. Okay. Yeah, I don't really think interviewers like care so much about stuff like that, like typos, because usually when you have an IDE, and look at that, 100%. Okay. So just a quick recap on how this is working. So the main bulk of the function is here. So you go through, So to get through permutations, a key concept is this right here. You go through you go through one thing, and then you add something to the permutation, you recursively call a function, and then you take it off. So that's like a pretty hard concept to understand, and maybe next time I will draw this out for you because that's not intuitive at all. So yeah, maybe next time, but I don't really have the tools to do that right now. So try to understand this concept. If you can't, leave a comment, and maybe I'll get back to it. Okay, so I want to finish by just looking if anybody else has something cool. This is the one I looked at, by the way, so thank you to VKR1997. You were helpful. Wow, 0 milliseconds, this guy.
Who are you talking to?
So let's just look through. Yeah, let's look. I mean, he claims he gets it in 0 milliseconds, but does he really? Vector result keys. Oh, this is kind of clever. So instead of a function to figure out what the output, what like the letters would be for a number, he has like it per index. For an individual index, he's just putting the string of that. Okay, if digits dot size is less than. God, this is such like disgusting formatting. I don't even like want to read this. Yeah, I'm okay. Let's pick another one. Let's just look up some C++ stuff using DepthFirst Search. Is that what we were using? No, we were using backtracking. That's what it's called, backtracking. Yes. Yeah. So he kind of has, this guy has the same idea. So if the index equals digits dot size, yeah, I guess that would be the same thing. Instead of like the permutation size, just looking if the index equals that would be equivalent. And then table digits minus digits index minus 0. Okay, so instead of, okay. What is table? Okay. This is his main function, and he made this table that has this. And this is how he's figuring out, how many things are in each index. So if it's like 7 or something, first, this is like a trick to turn a character number into a number. You subtract it by the character 0. And yeah, so after he does that, he actually turns it into a number. And then he pushed back this for like certain numbers. So then like it gets the size 4 if it's 7, for example. And anyway, so I think he's gonna be doing the same thing. So he pushes back. Right. Okay, so another thing for strings, I mean, concatenating is just like a lot cooler, but whatever. Pushback is cool too, I guess. So you're pushing back. Yeah, he's using this table. Then he backtracks. What's he backtracking with? He has result. Oh, okay. So I kept, like, for example, I kept these as private variables. Result. I kept table as an actual function. And I kept digits as a private variable also. So that's why it looks like he has so much. But it's the same idea. So, like, backtracking's definitely important for these coding interviews. I just want to look at one more that's not backtracking. This DepthFirst Search kind of caught my eye. Okay, so DepthFirst Search. Wow, that is a pretty short function here. Just return the string. I'm probably reading that wrong. Oh, wait, that's not a function. Wait, I'm confused. Where's the function? Oh, okay. You see, he has no indentation. Okay, vector string string. This is the final result. Save temporary depth first search. So he's calling DFS. So DFS takes a lot of stuff in. The solution, the save, the digit, the now, the size, the convert. If it equals size, push back, save. And if it doesn't equal size, what do you want to do? Oh, this is all part of it. Oh my gosh. Oh, this is like honestly the same thing. So, okay, depth first search and backtracking I guess are pretty similar. How would you discuss with which to apply? What are the vehicles, the grass and edges? Yeah, I would have to agree. I don't know if I see how this is. Oh no, okay. Yeah, I do see how this is depth first search because it's like you have a tree and you're like adding all the things in this row and then you add all of the ones in the next row and whatever, and you so like after you add this edge. Oh wait, no, that's a breadth first search. It's a depth first search because you go all the way down the tree, then you pop back up and go here, then you pop back up here and then go this way, and so on and so forth. So yeah, it's the same concept again. You push back something, call the function so it does it again, and then you pop that last one off. Okay. Thanks guys for hopefully this was informational and relaxing, and I hope to get better at explaining these problems as we go on, and I hope to get better at them myself, and I hope that you guys get better. But yeah, so we got it done after some struggling, as you can see. I started this a while ago, actually. But yeah, these medium problems are like not that mediumly easy. You know, if I took this, I feel like if I did this stuff like a year ago when I took a course like this, I would have been a lot better at this. I should have kept it up in 281. Oh well. Well, I hope you enjoyed this video, and I'll see you next time on Casual Code Talk. See ya.